Good day, everyone. This video will assist all grades from grade 8 to 12 in mathematics. Particularly, we are interested in looking at how the distribution of the square root is correctly done in a sum, a difference, a product, or a quotient of any two numbers. In other words, we want to address these four questions. First of all, is the square root of a plus b equal to the square root of a plus the square root of b? Let us give specific values of a and b. Let's take the value of a as 9 and the value of b as, let's say, 16. We know that the square root of 9 plus 16 will be equal to the square root of 25, because 16 plus 9 is 25, and the square root of 25 is 5. Okay, but can we distribute the square root to these two numbers to say the square root of 9 plus the square root of 16? What do we get for this? We get 3, but for this we get 4. 3 plus 4 will give you 7, but the correct result is 5, which means this is not correct. Therefore, the square root of a sum of two numbers is not equal to the sum of the square roots of the individual numbers. So the first one is no. You cannot distribute the square root sign to a sum of those two numbers. Let us look at the next one. What about a difference between two numbers? Is the square root of a difference equal to the difference of the square roots? Let's address it again using specific values. Let's take our a as 25 and let's take our b as 16. Okay. We want to see if the square root of 25 minus 16 will be equal to the square root of 25 minus the square root of 16. So we make a breakdown. Is it equal to the square root of 25 minus the square root of 16? Okay. 25 minus 16 will give you 9. But the square root of 9 is 3. Let's look at the right-hand side. The square root of 25 is 5. What about that of 16? It's 4. What is 5 minus 4? It's 1. So the left-hand side is not the same as the right-hand side. Therefore, we cannot distribute the square root to a difference of two numbers. In other words, the square root of a difference is not equal to the difference of the two square roots. So it's a no, as illustrated by that. Now, let us proceed to the product of two numbers. What about the square root of a times b? Can I split it in this manner and get the same result? This time, I'm going to choose different numbers altogether. Let me choose the square root of, let's say, 16 times 4. Okay? I know that 16 multiplied by 4 is 64. And the square root of 64 is 8. Right. 16 times 4 is 64. Its square root is 8. This is the correct thing. Let's check if I decide to partition this into the square root of 16 multiplied by the square root of 4. What happens? The square root of 16 is 4. The square root of 4 is 2. 4 multiplied by 2 gives us 8, which is also equal to what is on the left-hand side. Therefore, for the product, it's 5. In other words, the square root of a product is equal to the product of the square roots. So we can partition, we can distribute the square root sign separately to the two multipliers, and we get the correct result, the left-hand side equal to the right-hand side. So for this one, it agrees. Let's check with the quotient. Part D. Is root A over B equal to root A over root B? Again, choose for yourself two numbers to replace A and B with. Okay, I'm going to take my A as 100 and my B as 25. Comfortable numbers that I know their individual square roots. Okay, ideally 100 over 25 is equal to 4. So this is equal to 4, and the square root of 4 is 2. Am I going to expect the same result if I say the square root of 100 divided by the square root of 25? Let's see. The square root of 100 is 10, and the square root of 25 is 5. Sorry, it's 5. So 5 into 10 gives you 2. Yeah, wonderful. So the left-hand side is 2, and the right-hand side is also giving me 2. Therefore, this is fine. What can we conclude? We can conclude that the square root of a quotient is equal to the quotient of the square roots of the two numbers that are dividing. So the distribution of the square root works for multiplication and for division, but never for addition and subtraction. Please don't split and expect to get the same result. This is very important. When we build up on these issues to cater for the cast diagram in your trigonometry, we have always experienced problems where, okay, someone is given that this is t and this is 1, for instance. Then they are looking for r. They will start very well with the theorem of Pythagoras and say r squared should be equal to 1 squared plus t squared, which is fine. Therefore, r shall be equal to the square root of 1 plus t squared. Now check. What I have here is a sum, and everything is under the square root. Am I going to split this and say the square root of 1 is 1, the square root of t squared is t, and expect that my answer is going to be 1 plus t? No, we have verified that that is incorrect. You cannot distribute the square root to a sum and expect to get the same result. So in this case, this shall remain as it is, square root of 1 plus t squared. You don't individualize the square roots. Thank you very much.